Welcome everyone, and thanks for joining my session. I'm Rich Dudley, the Chief Evangelist for N Software, and today I'll be demystifying the source control system named Git. Git is probably the most popular source control system in use today, but there are others still in wide use. My goal with this session is not to convince you to switch to Git, or that Git is the greatest, but just to help anyone who doesn't know much about Git understand what the love is all about. As for me, I was an ardent Subversion user for almost 10 years. I changed jobs to a company which was implementing TFS. TFS was horrible. That lasted a year until the developers nearly revolted and we began using Git. I used Git for over 10 years. I mentored teammates in Git and helped write some of the internal Git practices. Now, I find myself back on Subversion here at N Software. We have decades of history in Subversion, numerous build pipelines and other activities tied to Subversion, and it works great for us. We have no plans on changing internally, although soon you'll start seeing some of our code samples hosted on GitHub. To get started, I want to briefly look at how version control has evolved over the last 50 years. This is helpful in understanding what makes Git so weird and popular. SCCS is generally acknowledged as the first real version control system. It was initially released inside of Bell Labs for development on Unix systems. This means version control is literally 50 years old. So no one should have any excuse not to know about it or use it. SCCS is only slightly more than making complete copies of files with a numbering scheme for the versions. Although no new development has occurred in decades, many Unix distros today still have SCCS built into the operating system. Diff, also developed by Bell Labs and released in 1974, was the original utility to compare differences between two files on a line-by-line basis. Previously, it was difficult to see exactly what changed, and the last commit won, frequently wiping out the work of others. In 1979, Bell Labs released Diff's successor, named Diff3. Diff3 could compare any three files and merge the changes or mark conflicts. Now, two sets of changes could be compared to a common base version and merged, allowing two people to work on the same files and compare to a common ancestor. This compare-merge-conflict strategy carries on today in all source control systems, whether they use Diff3 directly or incorporate the strategy into their own tooling. A few years later, in 1982, RCS was released. RCS may be the oldest version control system still under active development. RCS is the first version control system to use reverse deltas, which means storing a complete copy of the file only once, and then just the instructions to make the changes for each revision. Ironically, today RCS's source code is hosted on a Git server run by the new project. A few years later, CVS was released. CVS is a front-end system for RCS, but adds repository change tracking rather than just tracking of individual files, and a client-server mode. Although its last revision was in 2008, CVS is still in use today. Its source code is hosted in a CVS repo run by the new project. CVS is one of two systems listed here which had a strong influence on the way Git is designed. BitKeeper was the original distributed source control system, a mantle which only Git and Mercurial have worn successfully since then. Even though the founder of BitKeeper was a contributor to the Linux kernel, the fact BitKeeper was commercial and proprietary did not sit well with other members of the kernel team. BitKeeper offered a free but feature-limited license for open source projects, including the Linux kernel. In the free license, BitKeeper hid the revision graphs, and a project to visualize them led to BitKeeper discontinuing its free for open source projects in 2005, including for the Linux kernel. Subversion was released the same year BitKeeper was. Because Subversion is open source, cross-platform, and had several modern GUIs, Subversion's popularity skyrocketed, it peaking in about 2006 or 2007. Subversion remains very popular today. It's probably the number 2 or number 3 most used version control system. There are a number of services offering Subversion hosting, and both Subversion and several GUIs are still under active development, so you're still in a good place using Subversion. Needing a new version control system for the Linux kernel and finding none to his liking, Linus Torvalds designed and developed the first beta release of Git in about 4 days. A few months later, Git managed the release of the Linux kernel 2.6.12. Mercurial was also spawned from the BitKeeper debacle. announced a few days after Git was announced, and was also an option for hosting the Linux kernel. Like Bitkeeper, Mercurial is also a distributed system and has many of the same goals as Git. Although Linux chose to use Git, Mercurial is still actively developed and used by Facebook, W3C, and Mozilla. Mercurial was actually a little more polished and popular than Git in the first year or so after their release. Bitbucket initially supported both Git and Mercurial, but dropped Mercurial in 2020 because surveys showed less than 1% of new projects used it and 90% of the developers were using Git. The release of TFS in 2006 led to a four-way race between Subversion, Git, Mercurial, and TFS for version control supremacy. TFS did not win that race. TFS has been morphed into Azure DevOps today and is not very popular, but is widely used because Microsoft. GitHub itself is not a version control system, but bears mentioning. GitHub is a web-based service for hosting Git repositories, but adds considerable amount of features on top of Git, which are so ubiquitous today, people often think they're basic Git functionality. The features and developer-friendly design and pricing, generous free options even after the Microsoft acquisition with GitHub, is probably the one thing most responsible for making Git as popular as it is today. To bring things full circle, Bitkeeper was open sourced in 2016, and today its source code is hosted on GitHub. Just a quick look at this timeline, and you can see a lot of activity from about 1990 to around 2005. But most development since 2008 has been just incremental. It's hard to say we've hit source control perfection, but since Git was released, there hasn't been anything nearly as disruptive. On the previous slide, I mentioned centralized and distributed version control systems. Both of those bear a little bit of an explanation. First, what we called a centralized version control system was simply known as version control until distributed systems emerged. Centralized version control systems is client-server. Client copies are known as working copies. Working copies usually have the full code base, but revision history is centralized to the server, although I think Subversion keeps revision history locally now. And files can be locked on the server, preventing their editing by other developers. In the really early days of version control, before diff tooling was widespread, file locking was the way to prevent multiple changes to the same file. Tools like diff3 kind of lessen the risk of multiple edits, but locking still persists to this day. Locking isn't really a problem until check-ins don't work right, or someone goes on vacation without check-in, and others need access to the locked files. Another feature of centralized version control systems are shelves. Shelves are how you store incomplete changes so you can work on something else, like stop working on a new feature, shelve the changes, make a hotfix on the trunk, then unshelve the changes, and get back to your feature work. Distributed version control systems utilize peer-to-peer style of collaboration. Every node can operate as both a client and a server, and has the complete copy of the code base and revision history stored locally. Since every node is equal, they're called clones. The update action is known as a pull, and the commit action is known as a push. With the advent of Git hosting services, the usual workflow today looks a little bit like a centralized version control system with slightly looser rules. In a true distributed version control systems, developers push and pull among each other until everyone agrees a release is ready. Then, someone cuts a release from the consensus commit. This worked for a while with the Linux kernel, but took a Herculean effort by Linus. This might be sustainable for a short while on small teams, but you'll quickly run into Metcalfe's law issues with each successive participant. Instead, there is usually a designated main or team or organization repository configured in a server-only mode, and this serves as the canonical copy of the codebase into which all merges are made and from which the latest updates are pulled. Being the designated org repo is the business model for GitHub. Developers can still push and pull from one another, which is helpful when debugging or refactoring some code, but this isn't a good idea as a main workflow, and in corporate environments may not work at all due to the security posture. When using a designated org repo, builds and releases should be made only from the org repo, since it's easier to centralize the tooling and ensure the changes have all been merged. It's the clean copy, since no one is working directly in that main repo. Distributed version control systems make it much easier to work disconnected, and you can test merges locally to prevent conflicts. Unlike centralized version control systems, there's no limit on the number of clones a developer can make. If you completely mess up a repo, you can just delete the folder and make a new clone. You can also make clones to test out new ideas or libraries without jeopardizing the main repo. There is no way to lock files in a true distributed version control system, all of which include tooling for examining and merging diffs for the time when two people are actually editing the same file. As it turns out, conflicts are rare even among large groups of developers, especially if you use a work ticketing system and open communication to keep two developers from working on exactly the same thing. With a distributed version control system, you're going to use branches frequently, to replace shelves, to work on a hotfix, or just try out a crazy idea. Branches are a mainstay of Git. The major downsides are some people have a hard time giving up the command and control structure of centralized systems, and the increased drive space needed for a complete clone of the repository, which really isn't a big deal given today's hard drive capacities. Development of Git happened under serious time pressure, so there was not a Git manifesto published, or even strategy or planning sessions. The goals on this slide were expressed by Torvalds in email discussion and archived on listservs, and were collected into various histories of Git. Other source control systems at the time took 30 seconds to merge a single patch. Linux would often have 250 merges at a time across all maintainers. Git's performance is usually 10 to 100 times faster than other systems, and the first alpha versions of Git were merging patches at about 7 per second. Although Torvalds had a strong disdain for CVS, Git does actually incorporate some features from CVS, notably the three-way merge. And Git keeps the distributed workflow which BitKeeper pioneered. The corruption safeguards aren't detailed in depth, but today these features include every clone having the full commit history and cryptographic hashes, the ability to walk a revision graph and revert, as well as multiple merge strategies. Linus Torvalds designed Git to be different from other source control management systems, aka version control systems, going so far as saying, "I have absolutely zero interest in creating a traditional source control management system." So if you wonder why Git seems so weird, this is why. Even the name is an allusion to Torvalds' attitude towards other systems. In British slang, Git means an unpleasant person. As we just discussed, Git is a distributed version control system designed to allow independent development and easy patching. It does, however, have its own nuances, which we'll review here. Every local clone is a complete copy of the main repo, and most importantly, everyone has the full commit history and full cryptographic authentication of the history. Now this is SHA hashes, not a blockchain. In case of disaster, any clone can serve as the main repo or be used to recreate it. This is very reassuring if you remember a time when hard drives would crash and you'd lose everything. Branches were designed expressly for nonlinear development, and you can use them, and you will use them often in Git. Many of the workflows emphasize working in feature branches, merging into the main branch only for the release. Branches can be made from any commit, so they're very useful when a hotfix is necessary. Git tracks changes at the directory level, and in large projects is very efficient compared to other systems, but single file operations are slightly less so. When you examine a single file, the operations still have to walk the entire change history, and it could take almost as long as a full project operation. Git is so efficient, it's unlikely you'll notice any burden at all. Merge conflicts are actually rare among experienced developers, and a good diff tool and merge strategy handles automatic merges without a lot of worry. Git can identify and merge changes using 3 different strategies, including the CVS-inspired three-way merge. Should any of these automatic merges fail, Git tells the developer manual editing is necessary. At no point is Git a last save wins system. Should a clone fall too many revisions behind the main trunk, the developer is notified to get the latest before attempting a pull request or a merge. Being designed for open source projects from the beginning, Git supports the ability to fork a project. This is used to resurrect a dead project or take an existing project in a different direction. Forking is useful in enterprises too, where boilerplate code is in a DevOps repository, which development teams fork and customize for their services. In the early days of Git, patches were sent via email or pulled directly from another clone. Hosted Git services added a pull request feature, which informed a project maintainer that a contributor had changes to merge. These changes could be reviewed and merged by the maintainer. Pull requests were added recently to core Git, so now there is a built-in notification mechanism for changes regardless of how you're using Git. File renames can be a real mess in some version control systems if you don't use the built-in rename function. Renames can look like massive diffs or a delete and add, which breaks the history of the file. Since Git works at a directory level, it tracks renames and maintains the commit history even if the file is renamed. Helping speed adoption and ease transition, Git has a CVS emulation mode as well as the ability for bidirectional updates with subversion repositories. Git also supports multiple protocols for communication between clones, including HTTPS and SSH. A few times now I've mentioned workflows, but what exactly is a Git workflow? I like to define a workflow as the pattern of activities you use when setting up repositories, forks, and clones, and then managing the changes to your codebase. Fork and pull is a simplified Git workflow, which I think is the easiest way to get started with hosted Git, as well as establish some good practices early on. I used this workflow for developers who are new to Git, as well as non-technical product owners and business architects who are contributing to documentation. The first part of this workflow is setting up a repository, forks, and clones. Start by creating an organization-level repo in a Git host. Developers then create personal forks of this repository, usually in the same hosting service, but because of the nature of Git, can be any hosted Git service. Developers then clone the organization repo to their development machines. The first remote reference in a local clone is named origin by default. Developers then add remote to create a reference to their fork using a personal alias. The key best practices here are cloning the org repo first, so that no matter what clone of whatever project you're working in, origin always points to that org repo. The other key practice is when adding your personal fork as a remote, give it an alias which refers to you, like a nickname or a user ID, anything like that. Use this same alias for all your projects. When you're tired or rushed, you don't want to have to think about which alias is the main repo and which is your personal fork. You can just rely on the muscle memory of which alias points to what. If you pull changes in a peer-to-peer arrangement from a teammate, you can use their nickname as your local clone reference as well. You'll notice that fork and pull looks more like a client-server style and less peer-to-peer than how Git was originally designed, and that's okay for getting started. The second half of fork and pull is managing the changes to your codebase, and it goes like this. Before starting work, or maybe periodically through the day, developers pull from origin to make sure they have the latest updates in their local clone. Developers do their work and commit changes to their local clone. Local commits are then pushed to the personal fork. A pull request is made from the personal fork to the organization repo. There, changes are reviewed and either approved and merged, or the pull request is closed and additional changes are requested. We found that pull requests could mostly replace code reviews. Feedback was faster, and so was turnaround time. The ability for other developers to comment on pull requests, which can be seen online and also sent to contributors, provides very atomic feedback. The downside to replacing code reviews with PRs is that PRs are very atomic. They're very focused on the changed lines of code. Are these lines of code well written? Do they do what they're supposed to do? Every once in a while, it's worth looking at how the code files are organized in your solution and that the system is meeting the architectural guidelines and practices you have in place. I'm now going to show you all how fork and pull works using GitHub and the Git command line. Although I'm going to do this demo in GitHub and the command line, it works pretty much the same in all Git hosts and GUIs. The UIs might look a bit different, but the process and commands are all the same. As we go through this demo, keep in mind that fork and pull may be the only workflow you ever need. I've presented it here as a starting point, but is good enough for large, important projects too. Here, I've logged into my GitHub account and created a demonstration organization. Signing up for GitHub and creating organizations is a little outside the scope of this session, but all the Git hosts have pretty good documentation. The first thing we need to do is create a new repository. So we'll just click that button, and we'll call it Delphicon 2023. All right, demo repo for Delphicon. Oop. Delphicon. Let's make it a public repository. A couple key things that we want to add here are a README file and a git ignore. Git has pre-templated ignore files. These are used to exclude files which shouldn't be checked in, like, say, user-specific settings, or binaries from a build process, or even that packages directory that we talked about earlier. They're pre-compiled for all kinds of different languages and editors. Delphi just scrolled by, so let's grab that one since that's what we're doing. And we can choose a license. If we're doing this as an open source project, we can choose a license which will be published in our repositories. Oh, I don't know. Let's do MIT. That's pretty permissive. And here, we just set it to create repository. And very quickly, we have our Delphicon 2023 repository with a license file, a README, and a git ignore already in place. So, step 1 is done. We have an organization repo. To create a fork, we just come up here to the fork button, tell it we want to create a fork, and it asks us where we want to create this fork. This is going to put it in my personal account and give it a repository the same name. We're only going to copy the main branch for now. Why not? It's the only one that's there. Then we just hit create fork, wait another moment, and there we have it. We now have a fork. Step 2 complete. And now it's time for step 3, creating our local clone from the org repo. To do that, we have to go back to the org repo, and we can just click this little breadcrumb here, and GitHub will take us back to the org repo. We're back. Under this green code button, if we pop that down, we'll find the addresses for each protocol we can use to clone this repo. We'll start with HTTPS. Clicking this little button copies that URL into the clipboard, save us some typing. And now we can bring up our git command line. We just do git clone, paste the address, hit enter, and in a few seconds, great. If we change directories to get in there and list the contents, you can see the git ignore, the license, and the README have all come down. We have an identical clone of our organization repo now. And now, step 4, creating a remote reference to our personal fork. To get back to our fork, all we need to do is come over here to the fork button, drop that down, select the fork that we created just a moment ago, and GitHub will take us back. Once again, under the green code button is the addresses we need. We'll copy the HTTPS one, pull up our command line window, git remote add, add, and here's where we give it an alias. I'm going to name this for me. Paste in the address. And there we go. We now have our repo, our fork, and our local clone all set up with the references from our local clone to the origin and our personal repo. If we want to confirm this, we can just use the command git remote, and it will list our two different remotes, an origin and a personal one. All right, cool. Now it's time to start making some changes to the files and going through the process of committing and pushing and pulling. In our folder, we can again see a README, a license, a git ignore, and a git control folder. Let's edit the README. Just right-click on that, bring up our favorite editor, Notepad++. Now, this is Markdown. If you've never seen this before, it's going to look weird, but it's a way to do markup with some very simple line initiators. Let's change this to be the classic hello world. This is a demo for Delphicon 2023. Hope everyone is learning something awesome. We'll save that. To see which files have changed in your repo, you can use a git status. And here it says on branch main, we've modified the README file. Good deal. Let's do a git commit with the command line toggle AM. The A stands for all files which changed. The M says include the message. Initial edit for the demo. You'll want to use some good commit messages. You'll thank yourself in the future. You're going to go through a lot of commits. The better your commit messages, the more you'll appreciate your present self. Great. So we've committed the changes locally. Let's do a git push R Dudley. These changes are going to be pushed up to my personal repo. Now let's check something out that's really cool. Here we can load README, and we can see the changes that we just made. Hello world. That's awesome. If we go back to the org repo and we display that README, you can see the changes are still what they were. They haven't been accepted yet. This is good. This means I've made changes locally and I've pushed them to my personal fork. What we do from here now is we create a pull request where we tell, well, in this case ourselves, I have changes to make to my own files. Going back to our personal repo, we just hit the pull request button. We say new pull request, and it will show us a diff of the files that we've edited. We can simply create a pull request and say, hey, this is ready to be reviewed. My typing skills are legendary. Also, we're going to create the pull request. Now, as you can see, this has moved us from our personal repo back into the demo org repo. If we want to see the number of commits and what went with those, we can click on the Commits tab, and GitHub shows us. This is the first commit, the initial edit for the demo. There's only one commit. To look at the files that changed and the differences between them, we just click on the Files Change tab, and here comes the diff. We've changed the pink into the green. To merge this, we just go back to the main tab, and we say, awesome job, dude. Click the Merge Pull Request button. Confirm the merge. And we've done it. We have made changes on our local clone, pushed them to our personal fork, merged them into the main repo. If we go to the Code tab, we can now see the changes are present in our README file. Outstanding. We have just made changes using a very simple Git workflow. The ability for Git hosts to display Markdown files in your repository is a very cool and very powerful feature. A README is a great way to welcome people to your project, to explain how to use it, to document your team commitments, or even to link to other Markdown files to form documentation. Every Git host supports Markdown, although some have some slightly different flavors than the classic Markdown. Here's what GitHub's looks like. It goes through and shows you how to do the different headers, how to make H1, H2, H3, H4. You can do lists, links, add images. It's a rudimentary style of markup that gets rendered into just basic HTML. If you plan on using a Git host and you haven't worked with Markdown before, take some time to learn Markdown. It's very powerful, very easy, and still pretty cool to use. Now that we've merged our pull request, there's one more thing we need to look at. Back in our org, we can see that we have all the changes here. But if we go to our personal fork, GitHub alerts us, hey, wait, there was a merge made to the org repo that is not reflected here. There's two ways that we can bring this into alignment. One is with this new sync fork button. Another way would be to go back through the fork and pull process, pull from origin, and push to our repo. Let's do it the hard way. Bring up our command line. We'll say git pull origin main. That will bring the commit history down to our local clone. We will git push R Dudley. And now the commit history, and only the commit history, is getting pushed up to our personal fork. That's great. If we come back here and reload this page, that message should go away because both repos have the same commit history. It does. This branch is up to date with our organization repo. Excellent. If there's one thing I've mentioned a number of times today, it's branches. Branches, branches, branches. You'll get to use a lot of branches if you use Git. They're very powerful, and they're an easy way to sequester some changes from other changes without affecting the main trunk. Let's see how this works. Again, I'll bring up the CLI. And although I'm using the CLI, most of the GUIs actually just automate the CLI. So the commands and everything are identically the same. To create a branch, all we have to do is say git branch and give the branch a name. Let's call it test. Good deal. If we want to confirm which branches we have, we just say git branch with no additional parameters, and Git will list the branches for us. The asterisk in green color on main tells us that that is the active branch. If we want to switch branches, we just say git checkout test. And now we've switched to the branch named test. And again, we can say git branch, and now we can see that the asterisk in green color indicates that test is the active branch. If we come into the file we were editing earlier, don't switch file branches with the editors open. We can now add some edits and say this is from the test branch. Excellent for us. We can save that. And doing our git status, Git tells us that on the branch named test, we've modified the README file. If we do a git checkout back to main, we can do a git status, and it says that our branch is up to date with origin main, but there's some changes on a different branch that we need to commit. So let's switch back to our test branch. We now tell it to commit all files with the message, creating the test branch. And we git push to the destination aliased for me and the branch we want to push. And if we wait a moment, GitHub will create a new branch and take the changes. Coming back to our repo, GitHub helpfully tells us, hey, there is a new branch created. We can compare and make a pull request. I want to look at something first. Here's the README on the main branch, and view all branches. We can switch to the test branch, and the README looks exactly like it's supposed to from the test branch. This is from the test branch. This is great. Now let's make a pull request from our personal fork back to the org repo, crossing branches. And we have two choices here when we make this pull request. We can either say, take the test branch from our personal fork and request it to be merged into the main branch of the org repo, or we can have it create a test branch in the main repo. Here we're just going to merge to main. Doing anything more than this and we start to deviate from the fork and pull, we get into a more advanced workflow, and I don't want to go there just yet. We are testing branches. Great, let's create the pull request. GitHub will teleport us back to the org repo with a pull request, which we can choose to merge. Normally you'd want to inspect these things, but for the sake of simplicity and time, we're just going to merge it here. Outstanding. If we go back to the code, we can see that this edit was made from the test branch. We're looking at the main branch in the org repo. This is how easy it is. One final thing to look at before we leave this demo. Let's go back to our personal fork. And remember again, this branch is 2 commits behind our Dudley demo main. We can just quickly sync that fork, update the branch, and now our personal fork has the same commit history as the org repo. Now that we've looked at our README file, let's take a peek at 2 of the other files that come out of the box with a GitHub repo. First, let's check out the MIT license. It's just the full text of an MIT license, including a summary of permissible uses at the top. That's pretty handy if you're starting open source projects and don't know which one you want to choose. You can choose a couple, pick through them, and see which one suits your needs. Also, the git ignore. This is a very powerful one because this is the one that tells Git what to exclude when it adds or updates files in your repositories. It's just a long list of things that can ignore. And you can edit this file. This is just a plain text file. You can add different things or take different things out. There's also the git ignore command, which will add to this file as well. Now that we've seen how to edit files and commit those changes, let's see how an add and delete works. Off camera, I've added a couple files to our repository. One is named add and one is named delete. I've already added the delete file and made a pull request to our main organization repository so we can see how a delete works without spending a lot of time in the demo. But let's see how to add a file. To add a file, we just use the command git add. And we have 2 options here. We can either name the file specifically using wildcards if necessary, or if we have a whole bunch of files, we can just use --all, and all the files will be added. If we do a git status, we'll see that we have a file that's ready to be added to the repositories. So we do our git commit -am adding a new file. Great message. And let's push it. While that's happening, let's come in here and also delete this file. Just like we said. Goodbye. We don't need that anymore. And we can do a git status again. And we see that now Git has detected we've deleted a file. So we can do again git commit deleted that file. And we'll push this. We could have done this in one commit, but I felt like doing 2. And now that commit has been made in our local or our personal fork. So if we come up to our personal fork, we don't see any changes yet. We can refresh this page. And we'll see that the add file is there, but the delete is already gone. How does this look in a pull request? Let's create one. Click the pull request tab, click the new pull request button, and we can see how Git displays these. Git shows the add file as an add, and then because the file was deleted, there's no diff. It's just marked as deleted. Now we can create a pull request and merge it just like we did previously. For the sake of time, and since we've already seen a pull request, we'll skip actually completing this pull request. Here's a list of the commands I used in the demo today. This is also included in the slides, but you can pause here if you need to and write them down. Any of the commands marked for the host UI, I did in the GitHub UI. All the other Git hosts will have similar ones, but you'll need to refer to their instructions to exactly how to perform these operations. Anything labeled as command line, I did in the CLI, but any of the Git desktop GUIs will also have the same commands with the same name. You'll notice there isn't a delete on here. That's because there isn't one in Git. You just delete a file through the file system, and the next commit picks up the change. That was a very quick but complete demo of how the fork and pull workflow works. When I would do this type of training at a previous employer, the presentation I used was called Git in 10 minutes, and people were amazed. Wow, that's all that it takes? It's not that hard. It's really not. Once you learn a few basic commands and a decent workflow, Git is very, very easy to use. After you get comfortable with the basics of working with Git, you can look at adding some intermediate practices. I demonstrated how branching works, and the next step is usually a branching strategy. When do you use branches? Do you merge from a branch directly into main and then make a pull request? Or do you make a pull request from a branch into main? Things like that. This is a team commitment you'll also want to document in your README file. You'll also want to add some branch protection rules to ensure no one accidentally pushes to the main branch if you don't want them to. All of the Git hosts have the ability to display Markdown files, and indeed we saw that in the demo. You can add extensive documentation which lives alongside your code or in a completely different repository using Markdown. There are utilities to extract code comments into Markdown files, which can also be a very powerful tool for documenting code libraries. Also, two-factor authentication. This doesn't have anything to do with Git. It has everything to do with protecting your account. Enable two-factor authentication. If you want to have something to read, like a book, on the Git website there are free electronic copies of the book Pro Git by Scott Chacon and Ben Straub. Scott is one of the founders of GitHub. Although this version of the book was published in 2014, the basics of Git have hardly changed since then, and this is still a very useful reference. Here are some additional Git best practices that you want to incorporate as you begin to use Git more and more. First of all, atomic commits. This means try not to mix multiple fixes or features into a single commit. Commits should have good messages, referencing a work item if you use those, and include only the changes for that work item or feature. Being familiar with Git workflows is worth the time. There are a lot of ways of using Git, and I've worked with teams who had a lot of trepidation getting started with new projects because they were worried they'd make a mistake in the setup or just couldn't figure out how they wanted to work. Additionally, different team members had different backgrounds with Git, and one may have wanted to use Git Flow and another use GitHub Flow, and the discussions were long-running. We sketched out the workflows on a whiteboard, discussed the pros and cons, the team agreed on one, we documented it, and off they went. And as they went, they modified it a little bit, making tweaks and documenting those tweaks. Do we add a branch here? When do we do this? When do we do that? As you begin finishing and releasing work, incorporate tags with each release. You're going to end up with a lot of commits, and tags are an easy way to find the last release. I get asked a lot about including packages in a repo. Unless it's a package you're developing, or you have some security reason to escrow a particular package, the answer is no. You'll bloat your repo horrendously and have conflicts in files you have no control over. Add your npm or NuGet or whatever to the ignored list. You do, however, want to commit the package as manifest, so that all developers are working with the same versions of the same packages. Git is very flexible in how you use it, and so documenting your team agreements on how to use it and contribute is a very good idea. This is a good use for a README file. Some of what you want to agree on are the branching strategy and workflow. Can pull requests replace code reviews? Can contributors merge their own changes, as I did in this demo? And so on. Every time you come to a decision point, talk it out with your team and then document it. Although you can self-host Git with just the daemon, I strongly recommend using something with more features. I demonstrated with GitHub, but there are other good Git hosts out there. I've used Bitbucket a lot also. It's quite good on its own, but really nice if you also use Jira or other related products. All the commercial hosts have generous free plans, which are great for small teams or individuals getting started. If you want to self-host your Git server, look at Gitee or Gogs. True to the form of Git, Gitee is a fork of Gogs. Both are open source and have many of the same source control features the commercial services have, and both claim to be able to be run on Raspberry Pi hardware. I recommend something a little more robust for your critical code, but apparently these two services don't take too many resources to run. There are a number of Git GUIs. I did the demonstration with the command line, but I personally use a combination of the command line and some IDE plugins. Git GUI, which is part of the Git package, it's okay. Tortoise Git will be familiar to anyone using Tortoise SVN. As with Tortoise SVN, Tortoise Git is free and open source. Tortoise Git needs a companion tool for resolving conflicts, however. Git Kraken is a powerful desktop GUI from the wonderful Axosoft company. There are free and paid options. Git Desktop is also free and open source and works with any Git host. GitHub Desktop also needs a companion tool for resolving conflicts. Almost any ID can also work as a Git client, although some need a plugin, but others work with Git out of the box. WinMerge, diffmerge, and Beyond Compare are good companion tools for editing conflicts. WinMerge is free and open source. Diffmerge and Beyond Compare have paid options. I've used both WinMerge and Beyond Compare in the past. WinMerge works just fine. Beyond Compare does a whole lot more than just merges and diffs, and it's worth the cost if you need those features. In addition to the standard Git bash command line that I showed earlier, PoshGit is a PowerShell client for Git. It's kind of cool, but I usually end up back at just the regular bash client. So, how to try Git. Hopefully by now, you're very inspired. Start by going to gitscm.com, download, and install the correct binaries. Install a GUI, maybe Tortoise Git or something else. Create an account with one of the hosting services. Create a Hello World repo like I just did here. Make a poll, make changes, do a push, branch and merge. Work with a friend and break things. Cause a conflict. Look at how the PRs work. Just goof around. You're not going to break anything. You'll learn a lot by just trying it. I want to thank everybody for tuning in today. Whatever time left, we'll dedicate to questions and answers. If we can't get to everything here, find me online. These are the 2 Twitter handles where you can find me.
Right, fantastic, great. Thank you, Rich. Sorry, I keep saying Richard. Hope that you're okay with that. If you want to come on, we'll do some Q&A here. There you are. Oh, your audio is really quiet now. So there's a few people chiming in about their favorite source controls. Another fans of Subversion out there as well. That's great. I always say find what works for you and just make sure it's working right. You know, I don't care what you used today.
Version 8, it's still under active development. Tortoise SV is a great client. It's very good. We use it as software. So like I said at the beginning, I started out on this version for many years, and I went to a company that used Git for 10, 11 years. Now I'm at a software back on Subversion.
So your audio is breaking up really bad.
I apologize.
It says your bandwidth is fine, but your video and your audio are garbled.
It's a driver issue on my laptop, so Windows apparently ruined my drivers. I have to drive through to run.
I'll go through some of the comments here while you're working on that. These technology, right? Lars says it takes a little time to get your head around Git, but it's worth the effort. I really appreciate the thing you said at the end about making a Hello World Git repo and just trying it out and stuff. I talk to people all the time. They're like, oh, I've watched the video on this. I think I'm up to speed on how to do it. And it's like, have you done it yet? And they're like, no. I'm like, if you haven't done it yet, you don't know what you're doing. It's like you're not going to learn to ride a bicycle or drive a car by reading a book or watching a video. And you know, it's the same thing with these. I think.
You can break anything.
Lars is a fan of Git Kraken. I mostly use pretty much what I use. I use the command line and GitHub Desktop mostly, I think. Oh wait, I use another one too. I can't remember where it is. Fork is another popular one as well. Let's see. Patrick chimed in and says, "Great session, Rich. Will be useful for many developers on YouTube after this event." Yeah. Again, if you're not using a source control, use source control. If you're like, I prefer Subversion versus Git, that's great. Just use something. Make sure you're using source control and you have a effective backup. And your cloud host technically shouldn't be considered a good backup. You need to have a secondary backup. Your video looks better now.
That was the auto.
A little bit here. Lars said, "I wish I had this presentation when we started using Git. It's great, thank you." There's a lot of good information there. Yeah, absolutely agreed. And I'm a big fan of Beyond Control too. Just got to shout that out there. Thomas has a question here. How do you resolve merge conflicts in DFM files? Is there a visual comparison tool, or do you just have to edit DFM by hand and visualize changes in your head? Well, you can use, DFM is as text, and you can resolve the merges as text. So you can see the differences in text there. That's what I'd recommend. I don't think Beyond Compare. Yeah, Beyond Compare doesn't do a form render. That would be a cool feature to add. Someone should make a feature request to them. What's the other tool? There's another add-in for Delphi, Project Magician, that standardizes your project file format, which keeps, because sometimes the project file reorder itself. With Project Magician, it stops that from happening, and that makes it much easier to resolve conflicts when you're checking in project files. Sylvan says, "Perfect explanation of version control. Thanks. I'm going to get a link to the replay and send it to my colleagues." Awesome. That's great.
We try going off video, see if that helps with the audio.
It's a little better. You're understandable. It's still a little garbled.
Okay.
Actually, that's getting better.
I apologize for that. Yeah.
Someone suggested it might be your gain's too high on your microphone. It might be clipping. Terry says, "Great companion to the Git video previously put out in a webinar that deals with using it throughout Studio." Yeah, I've used, and you mentioned this as well, Richard. You used it with a number of different IDE plugins, a number of different GUIs. I still find I use the command line a lot, and I think there's a lot of times there's advantages. I use it from Rad Studio. I use it from different GUIs, but I still think at the end of the day, having the command line as well is really important.
And that's all the base commands too. A lot of the UIs just automate the command anyway.
Yeah. The GUI makes you more productive, but at the end of the day, command lines get all the power. Because if you think about it, the command line is just a wrapper around, or I'm sorry, the GUI is a wrapper around the same APIs exposed to the command line. Martin, if there's specific features you want to see around Git improvements for Rad Studio, submit them as a feature request on quality.embarcadero.com. And John saying he wants to build a GUI, his own GUI for Git. That would be awesome. I run into a number of command line tools that I'm like, I need a GUI that just wraps up these certain features here to make me more productive. I like your comment here, Rich. Yes, I always do talk to myself when using the command line. Me too.
Yeah,
Lars says, what's using... Yeah, when working from home, yeah. All the times you're the only one you talk to. This is a good tip. I don't think I've had too much trouble with Delphi having files locked, but it is something to be aware of, is that sometimes you have files locked. So make sure, especially databases. If you have a database open, that's the one that gets me the most. Okay. Well, sorry again for the audio issues. Here's a comment here from... Before committing updates, I always check to change DFM files. Really important. I'm getting an audio echo from the trainers off here. I'm getting echo back from you, Rich. I'm going to mute you for a second. If they're really important changes, or if it's just focus, tab change, or position, or some GUI elements falsely moved. Yeah, so that's a decent point. And actually, your comment about atomic commits, so important. I was a development team lead for a while, and I had one developer that was notorious for going in to fix a bug or add a feature and would see other code. He's like, I don't know what this is doing. I'm going to just take this out, or that looks wrong. It would just change all sorts of stuff everywhere. It always caused problems. So yeah, if you're going and making atomic commits, then that makes it much easier to resolve DFM changes, right? Because you're like, I didn't change anything in the DFM. Then you know you don't need to. You can keep the ones on the server. All right, I unmuted you. If there's anything else you want to add.
I think the slides available, Jim, we can get them out like PDF. Some use, so I imagine the slides might be handy too.
Yeah, we'll follow up and get slides and everything from you later and get those posted so that they're available. Although if you want to add them to your blog as well, you can do that. And then, Martha will follow up with you later and get slides and code from everybody, and we'll have a blog post with everything available. So.
Cool.
Fantastic. Sylvan says, about DFM, sometimes I got differences with explicit top and left appearing and disappearing without understanding it. Any idea? I don't know offhand. Again, my rule of thumb is, like Rich was saying, atomic commits, right? So if you're not making a change to the DFM, don't check it in, right? If there's a change in the DFM and you didn't make a change, doesn't matter. But if you are going in and making changes to DFM, then just commit it. Now, if there's a conflict, then that gets a little more complicated. Yeah, you'd have to resolve it locally, make sure it still worked, which is a good practice anyway. Even if you're resolving conflicts in code, you make sure your code still works after resolving those conflicts before committing it.